5.5 Part 4 is trigonometric equations with more than one trig function. Alright, so it also gives us a hint here. It says recall that if we have to square both sides of an equation, that sometimes that produces extraneous solutions. So, if you have to square both sides of the equation, you have to check all possible solutions. Alright, so look at example 1. It says find all the solutions in the interval from 0 to 2 pi of that equation. Well, again, we've got two different types of equations here, or two different trig functions, We have sine squared and we have cosine. And so there's some relationship there in which I need to be able to change them to just one equation, or one trig function, So either they both need to be a sine or they both need to be a cosine. Well, what do we know about sine squared? Because we know a lot of stuff about the squared functions. What do we know about sine squared that might take us to cosine? Well, remember that sine squared plus cosine squared equals 1. And so if I work this out to get sine squared by itself, we know that sine squared of x is equal to 1 minus cosine squared of x. So since I know that's true, I can substitute that in. So 2 times, we said sine squared is 1 minus cosine squared. I'm going to put theta here. And then I have minus cosine of theta minus 1 equals 0. Well, let's just simplify here so we can distribute the 2. And then I see I've got like terms here, so I'm going to combine them. So I got my negative 2 cosine squared of theta minus cosine of theta, and 2 minus 1 is 1 equals 0. Well, now this looks a lot like the previous example where we could factor it, but personally I don't like to factor with a negative in front. So I'm going to divide everything by negative 1. So it gives me 2 cosine squared of theta plus cosine of theta minus 1 equals 0. And now we can just factor this like we did before. Now this time I'm not going to use substitution. I'm just going to do it leaving cosine as cosine here. So when I multiply, I have cosine squared of theta plus cosine of theta minus 2. Simple trinomial. I know to get that cosine squared, it has to be cosine times cosine. And then I'm looking for two numbers that multiply to 2 that subtract to the 1 right there. So that's 2 and 1. Bigger number first. So it's going to be a positive 2. And 2 times what gives me a negative 2 and negative 1. Don't forget, because you multiplied, you got to bring it back and divide. And so we got cosine of theta plus 1 times 2 cosine of theta minus 1 equals 0. And now we're at the same step we were in the previous equation, or previous example there, where now we got two things being multiplied. It's equal to 0, so we can set them each equal to 0 and solve. So cosine of theta plus 1 equals 0, and 2 cosine of theta minus 1 equals 0. So I'm going to solve this first one for cosine. So cosine of theta is a negative 1. I'm going to solve the second one for cosine. So 2 cosine of theta equals 1. And we end up with cosine of theta equals 1/2. Alright, then we go through and do just like we had done before. So for this first one, cosine of theta equals negative 1. Remember, it's a whole number. It's probably a quadrantal angle. And so let's see, cosine is my x value. Where is x equal to negative 1? That would be at pi. Then we've got cosine of theta is equal to 1/2. Well, cosine is positive, so we're looking at quadrants 1 and 4. Cosine is your x value, so where in quadrant 1 is x equal to 1/2? Pi over 3. And where in quadrant 4 is x equal to 1/2? And that would be at 5 pi over 3. And so there are my 3 solutions.